I hope you all love networking because I love networking. Yeah, and welcome everyone. Yep, as we get started, so let me share my screen first, and then let's see. Okay, is my screen visible?
Yes, it's visible.
Perfect. So, welcome everyone once again. I am Pauline Namwakira. I am a trainer. I love training. Apart from training, I love networking, both as a technical topic, but also networking with you guys. So, hopefully, after this session, we'll network more and get to know each other as well. So, we'll be diving deeper into networking in AWS. How does networking actually power our digital world in this case? Now, yeah, I'll just dive directly into it. What are our module objectives? Like, what are your expectations as well? And then I'll ask a poll question as well. So, first, we'll just have an understanding of what is networking, what are some of the basics of the networking concepts that you are supposed to understand. We have private, public networks. What are they and where do we use them? Things like virtual private gateways. You normally set up VPNs to watch movies from the US, but you're here. But how is that different from the VPN in cloud? How do you set up hybrid deployments? Normally here we have our own data center somewhere. How do you connect that to the cloud? What are the layers of security that we do have to put within our networks? And yeah, some of the services our customers interact with. So just a poll question to check on all of you and how you're doing. On a scale of, what is a good scale? On a scale of 1 to 10, let's say, like, how confident are you with networking? Zero being, yeah, it can't be, I don't know something. Zero being what? Yeah, I am like an expert, and 10 being, I am a, super expert. So you can put like your responses on the chat. Yeah, I didn't ask much, just a 0 to 10 scale. Like 0 being expert, 10 being super expert. Okay, Nathan is a solid 7. I love that. Karen is an expert in networking. Rachel, voice good. I see Victor there, 3. Oh, Anastasia, come teach the class. We do have Alan somewhere in the middle. Franco is also my fellow teacher. Jimmy 6, 7. Okay, good stuff going on in there. So for me, I think I'm a solid 0. Kevin is wondering which kind of networking. So people networking 10, I agree. AWS networking 7. Okay, expert, we are sorry. It's good that you good in networking both ends. So thank you for collaborating with me. And now, yeah, I asked that because I want to keep that energy going on within the chat. Anyone above 5 to 7? 5 to, no one gave me a 10. 5 to 10 in AWS networking. We'll be teaching this course together in here or this module. Oscar, you're just here to find out. You're welcome. You're a 0 expert like me. Hopefully, I get you to, a 7, somewhere around a 7 or a 10, if I could. Okay. So now looking on to, the module topics that we have available. So the cloud that I'm focusing on is AWS, yeah? So Google people, Azure people, no shade. I am into AWS. Karen is hoping to get into a solid 7. Yeah, we'll try. So our module topics will be covering, VPC, basically because that is literally the network. When you talk about what is a network in AWS, we normally talk about VPC and so on. So we'll discuss VPC and its components, and sub-components and sub-sub-components if they exist. And then the next topic we'll now dive into, after understanding what the network is. Our second thing is to understand how do we secure our network. So we'll be getting into the firewalls. And then after that, now that we know what a network is and how we build a network in AWS, our next focus will be interconnectivity. Now, how do we connect multiple networks? So hopefully this knowledge will be enough to get us to a 7, somewhere and so on. Okay, so now before we get into networking, before I jump into AWS and bump you with a lot of words, so I want us to paint a picture. Imagine you own a coffee shop. If you have taken breakfast, well and good. If you have not, welcome to my coffee shop right now. So the customers walk in and place their orders, of course, with the cashier and so on. The cashier is going to take that order, process that order, maybe process your payment, and pass that order to the barista. Now, the barista is going to make your coffee. So, what happens if our customers or some of our customers, like me, the stubborn ones, we want to skip this queue that is over here and talk directly to the barista? So what is going to end up happening is some sort of chaos where the barista does not know, okay, who even paid for the coffee? Like, what is next? What should I make next? And in some way, the orders are going to get lost. The customers are going to get frustrated. And why am I taking you to this coffee shop? So this is exactly what happens in networking if we don't have a proper control. Now, the importance of networking is to understand, have a clear path. How does traffic flow? From where to where? And we need rules to know who accesses what. So to fix this, you as the owner of the coffee shop, you divide the counter area. So in the counter area, you place the cashier in some, public facing place in a separate workstation. So this cashier workstation is going to be public facing and designed to receive our customers as well. And then we make sure the barista's area is going to be private. So the barista can still receive orders from the cashier, but cannot interact directly with the customers. And now that brings us to, how do we use AWS networking service to isolate resources and figure out exactly how traffic is going to flow? So now we're thinking about millions of customers are using AWS services. Now, imagine all these millions of customers have also created their compute workloads and so on. So if we don't have such boundaries, we are going to go into the problem we saw in the first slide. So we would allow network traffic flowing unrestricted. And now a networking service that is going to allow us to establish these boundaries. So the network itself being the hotel, but then we have boundaries where we have public subnetworks and private subnetworks, is the VPC, Virtual Private Cloud. So topic number 1, we'll start with the Virtual Private Cloud. And in my own opinion, the Virtual Private Cloud is my hotel. So, the people who are 5 to 10, maybe you can let us know, what is your understanding of VPC? To me, it's the hotel I'm building. What is your, how do what is the terminology you use to describe a VPC? I think are people allowed to unmute? Yeah, if you can raise your hand and mute or put it on the chat as well. Let's make this interactive. What is VPC to you? Oh, you can also copy what I said. You can say it's the hotel or our coffee shop. Ah, nice, Alan. You see? So the VPC, according to Alan, is now the house that is going to host our coffee shop. Who else? Anyone? Even you can bring in those big terminologies you have from AWS. Aha, I can see an isolated geographical area. Okay, thank you. I am scared for, I'm going to torture your name. You can let me know the pronunciation. So if I torture, forgive me. We'll fight behind the tents. I think it's Ijeoma, but let bring the fight. Okay, Ijeoma. Thank you. Anyone else? Maybe a that response. What is a VPC to you? And We continue. Uh, uh, Felix thinks some sort of a data center. Okay, okay. So keep them responses coming. I'll always check them out. Kevin, please. So Kevin says it is the Matatu circle that will work during the strike. Okay, you let us know how that works out. Okay, so VPC, we have the AWS terminology whereby we normally say a VPC is an isolated, section of the AWS cloud. That is AWS textbook. So we are isolated section of the AWS cloud. And in this isolated section, you can launch, resources in a virtual network that you define. So the VPC, in my analogy that I had before, is this counter area that we had in our coffee shop. And in that counter area, I can, isolate my workload. So it is belonging to my hotel and so on. And now, in that counter area, I can have the public workstation and the private workstation. And this is what we call VPC is the network, isolated network of the AWS cloud. So this, if I am subdividing this network, that brings the word subnet, the subdivision of a network. And now that means I can have a public subnet and a private subnet. So that is it. An area, an isolated section where you can build your own network within the cloud. So what are we getting? We can isolate our cloud workloads. We can set up access controls and policies as well, however we want. Now, when it comes to, networking, sometimes you need to understand that is the AWS global infrastructure. So where is AWS is always the question you're going to ask. So how is it subdivided? We do have the region and the availability zone and the data center. So because this is not a global infrastructure session, AWS people, kindly let us know what is a region, an availability zone, and a data center, and how they are related to each other on the chart. I'll be coming to that. But for now, what I'm saying is, a VPC has to be within a specific region. The region could be, the African region, geographical location. And then we'll have a VPC over there. And now we can see some numbers in here. What are these numbers? So before we dive deeper, now let me take you back to some numbers that we need to understand. So these numbers are normally related to IP addressing. No one has told me what a region is and an availability zone. I'm waiting. Joel, okay, I see that. VPC, like a private island. Uh-huh. Uh-huh. Now, next, region AZ data center, DC. I'm waiting for that. So, these numbers that we are talking about, let me take you back. I love using analogies in my training. So, what is IP addressing? Every device you needs an IP address if it needs to access the network or the internet. So you normally check what is the IP address of my laptop, what is the IP address of what? The definition of an IP address. IP address enables like devices to access the network and so on. So it's a unique number, assigned to a device so that your device is able to connect with another or communicate with another device on the network. So in short, my laptop, if it needs network access, it needs an IP address. Now, an analogy I use is the room number. Like every room number, if I have a hotel, today I'm using the hotel thingy a lot. I have the whole hotel. The hotel name is the whole building. So the hotel will be called, what? What will I call my hotel again? Geez, give me names of hotels. I'm about to call it Pauline. I'm bad at namings and so on. Thank you, geez, Weston. So we have the hotel name Weston. And inside, really, all of you know Weston only. Geez. Yeah. So we have a hotel called Weston, and that is the whole hotel. And inside that hotel, we will have some rooms. And even before we have rooms, we have floors. So don't worry about my hotel, whose first floor is at the very top. So in this hotel, I'll have like the first floor here, the second floor, and the third floor. And then the other number that is going to remain over here, I'm going to assign to rooms. Like for example, so 10.0 represents the hotel, and then first floor, and then after first floor, room number 1. And that is the IP address I give to my room. So it's basically the way I, assign some unique numbers to my room so that someone cannot confuse any two rooms. So you'll know that I am in, room number 2 in third floor. Don't worry that my third floor is literally first floor in this case. So what you're seeing over here, each room is going to get its own specific IP address. Now, this is the IP address. This represents the network range, so subnetwork. And then this bigger number, 10.0.0.0, will represent the hotel itself, which is the bigger network. And now, what is this number /16? So /16, I'll use an analogy. It represents how many rooms are we going to get in that hotel. So for example, if you use /16, I won't go deeper into how IP addressing works, but this IP address we normally say has like 32 bits. So if we say like /16, we just mean 16 of those bits, are available to name our rooms. So if you do 2 to the power of 16, because you're talking binary, you'll get around 65K rooms in there. So you can imagine, just imagine that my room has 65K, my hotel. But now this just means these are the number of devices that can get IP addresses. Like if I go 10.0.0.1, .2.3.4.5, I finish that, I start 10.0.1.0, .1.1.1.2, I'll get a combination of around 65K. And then the smaller the room, you just do 32 minus 24, which will give us what, 8. So 2 to the power of 8, you'll get around 256 rooms. So these rooms, what I'm saying is just the number of addresses available to host. And the host is a device within a network. So I hope we are together at this point in time. So this is how you get IP addresses. Any IP address you have right now belongs to the network that you are part of. The network being like the hotel, the IP address being the room number, the sub-network being like the room floor. The floor, yeah. So someone answered me about region being a geographical place where we have the data center being a physical facility that houses the compute resources. Thank you so much. And I have not gotten the answer of what is an availability zone. So someone already said region is a geographical area. So now you know when I say a VPC is within a single region, that means it has to be in a specific geographical area. Okay, I'm done with the numbers. Now back to my VPC because you'll see a lot of numbers in there. I have discussed the subdivision of the network. We are segmenting our network, which is our VPC, and getting resources in there. As I have mentioned, in our hotel, we said the cashier is going to be public facing, and the barista is going to be private facing. So that subdivision of the network is what we call subnets, and subnets can be public or private. Public meaning they can host public AWS resources, like your servers that are public facing. You have hosted a website. How are customers going to access that website? It has to be public facing. And private, you can put things like databases in there. Like you don't want people on the internet having access to your database, right? So we put them in the private subnet and so on. Diving a little bit deeper. So a subnet is a subset of the VPC CIDR block. This is the big number I showed you before. So if our VPC was given this network, like 172.31.00/16, all our subnets will get like a number from this VPC. So you'll see they have like, it's a subset of the VPC in that case. And slash 20, I told you what to do, 32 minus 20. Whatever you get, 2 to the power of that number, you'll get around those IP addresses. So those are the available IP addresses that you can give or assign to your devices, within that specific subnetwork. Still, someone hasn't told me what an availability zone is. And I'm waiting. Thank you, Ernest. So, an AZ is a fully isolated physical grouping of one or more data centers within a region. Thank you so much. So someone told me the region is a geographical location, Kenya. Uh, Not really, I'm just giving an example. And then Ernest says an availability zone is a grouping of more data centers, and then we have the data center, which is a physical building. So that means that if we have 2 or 3 buildings, we group them, they become an availability zone. And then if we have more availability zone, which is like 3 other buildings, and we group this becomes a region. So region could be Kenya, and then availability zone could be, Nairobi, Mombasa, whatever. And then the data centers are, like, for example, in Nairobi, I love food, so I'll always talk about food. You won't have like just one Pizza Inn in Nairobi. You'll have a Pizza Inn in Westlands, a Pizza Inn in Kasarani, and so on. So those are physical locations where Pizza Inn is in, and so on. So that is the data center itself. So now we are saying a subnet resides in an availability zone. So it resides here. But a VPC resides at the region level. 5 addresses. We have talked about this number. So we are told this subnet is giving us 4K addresses. 5 of them are going to be reserved. But for what? So within a network, remember AWS is building this network for us. And let me go here. So we have 5 addresses that are going to be reserved. In a normal network, like a traditional network, we only said 2. So let's say our address was 10.0.0.0. That was our network / whatever. So, and I say like address number 1, 10.0.0.1. That is address number 1. Traditionally, we used to reserve this and said, oh, this is 0. This belongs to the network itself. And then the last one, maybe 10.0.0.255. You'll realize 255 is the last number we can have here. We said this is used for broadcasting. So broadcast is sending a message to multiple servers at the same time, the same message. But AWS reserves 5, not 2. So which is the first one? This was my network. 10.0.0.0 will be reserved for the network. The second, this .1 will be reserved for what? Who knows? 10.2.3, 1, 2, 3, 4, and the last one, .255. So we know the first one is for the network. This one is for broadcast. The second address is normally reserved for the router. So of course they need a router somewhere. When you there is a data center, so it has a router. The router that you have like in your living room, but just a router for the data center. Because you are not accessing that physically, something has to be reserved. An IP address needs to be reserved for that. So AWS will reserve this one for the router. The third one will be reserved for the DNS. And we'll be discussing DNS later on at the very end of the course. And then the third one, AWS says future use. I have no idea what future use is, but just know this, it's actually the fourth one. This is 1, 2, 3, 4, and 5. The fourth address is reserved for future use. And yeah, I don't know what future is. Use is. If you ever know what future is, use is, come and let me know. So those 5 addresses are reserved. So that means that if I have 4K addresses, just know that you are only going to use 3,995 of those because 5 have been reserved. Okay, so that is one thing to note. What makes a subnet public? Will be my next question. What makes a subnet public? Do I just name it public and we'll do a demo on that as well? And then it becomes public? No. For a subnet to be public, it needs access to the internet. And how does it get access to the internet? We need a gate. So we had our hotel room or our coffee shop. For people to get into the coffee shop, we need a door. If there is no door, then people cannot get in. So we need a gate, and that is where the internet gateway comes in. It's literally the gate to the internet, and it sits somewhere here on the VPC, allowing communication from resources which are private to the internet, and even users from the internet to access our services. Apart from the gate, what do we need? We need a map. And the route table is what I call a map because it's telling you, okay, if you need to go to the internet, you know you should go where? Through this gate called the internet gateway. So the route table contains a route. It's like a table which says, if you want to communicate with this other server here, that's okay. That traffic is within my network. You just go the lift, take the lift, and you'll access that. But if you want to communicate to the internet, you know what? There is a rule, you should go through the internet gateway. So that is the second thing. And the third thing, of course, the resource itself that you're trying to access should have a public IP address. And that is an IP address that is reachable from the internet. So these three things are needed for your resource to actually, be accessible on the internet. And this is what makes a subnet public. Internet gateway, very simple. It just allows you to send a request to the internet. The client can connect to your service through the internet gateway, and also your services, which are public facing, can connect to your client through the internet gateway. The route table, here is an example of a route table. It's literally the router, like the router that your VPC has. And you can just think of it like Google Map, or a map. If you want to go here, go through this route. So here you can see the destination. We are saying traffic within this network, that is the VPC network, is local. Like, you are local. If you are within your gate or your compound, you can walk around from one room to another, to the parking lot without any problems. So local traffic, an example, we are in this VPC. We have this server, needs to access server 2. That is allowed by default because the traffic is within the network boundary. And then we say rule number 2. If you want to access the outside world, anytime you see this address, it just means any or all, or internet. So if you are trying to access anything else that is not within my compound, then you can access that through this gate, the internet gateway. So that is what the route table does. It just contains a set of routes on how to access. And you can see the difference. For a private route table, it only has the local route, traffic within the same specific network, and no route to the internet. So you use route tables to control where traffic is going to. Private subnets, simple. They can't reach the internet, but they allow indirect access. And that takes us to how exactly, because they do not have a route to the internet. How are they going to access the internet then? And do they even need access to the internet, and so on? So let me give an analogy, because I love analogies as well. I know we don't love our president, so we will choose the president of Rwanda. So the president of Rwanda needs to, talk to Kevin Tuwei. So he had Kevin Tuwei, this big name in tech, and he wants Kevin Tuwei to come and talk in his conference in Rwanda. It is very unlikely that the president will directly phone Kevin Tuwei. In that case, Nimbaya, I know. So it's likely that the president is going to use, who is here, Karen, and say that, Karen is now the president's spokesperson, and say, Karen, there is this big guy called Kevin Tuwei. I actually need him in my conference about AI and whatever. Can you go talk to him and let me know if he'll be available? So the president will talk to Karen. President is private. Like, we don't access him on State House. Karen comes and now talks to Kevin Tuwei, who is out here. Kevin ako soko. Anyway, that is a joke. That is the internet. So Kevin is out here with us. So Oh, he's not. Trust me, he's not. So now, when you go back, when Karen gets a response, he'll come back and, tell the president, okay, Kevin says he's available and so on. That is one thing. What I'm trying to say, the private resource, which is like in a private subnet, our database, wanted to access people or, resources in the outside world, but he had to initiate that request. But he did not go on his own. He had to go through a spokesperson. And that spokesperson is what we call the NAT gateway. And the NAT gateway will reach out to the internet and allow the response only if the response, like is a response from Kevin. It's a response from the request it's initiated. But now, Pauline, being a comrade out here, had Kevin was called to State House. Pauline now comes in and says, by the way, Kevin, who reached out to you? And then Kevin tells me, it's this lady called Karen. Can you give me her phone number? And Kevin is like, okay, I'm not a selfish person. Here is Karen's number. And now Pauline, with all her whatever, she goes to Karen. Karen, I hear you are the spokesperson to the president. I actually want to talk to him. You know what Karen will do? Karen will just block me right there because she'll be like, who are you? Trying to initiate conversation with the president. We do not know you. I am the only one allowed to talk to people, and I am only allowing a response if it's a response to my request. That is exactly how the private resources access the internet. Why would they need? For example, we have a database server here. Of course, we don't want people in the internet trying to access, database, what do you have in there? No. But the database might want to download some patches. It might want to upgrade itself. And where is it going to get these files to upgrade from? The internet. So it's going to use the NAT gateway, which is in the public subnet, to access the internet. And the NAT gateway will only allow traffic back if the traffic is a response to the request from the database server. If it is not a response, anyone out here just trying to access that database server, the traffic will be blocked because you cannot initiate inbound traffic. Only outbound traffic is allowed and a response to the outbound traffic. So I hope you now understand how NAT gateway works in AWS. We are using NAT to protect our private IP addresses. So if this server, which is in our private subnet, needs to access the internet, it will go through the NAT gateway, which is in the public subnet. The NAT gateway sends that to the internet gateway to the internet, and it will only allow traffic back if it is a response to the request it made. Any traffic initiated from the outside world is going to be blocked, and so on. So NAT gateway will have its own elastic IP, which is just a public static IP that will allow communication. And the internet gateway just knows the NAT gateway. So even if someone tries whatever, they can only end up here because only the NAT gateway understands where the traffic is coming from. So if you are connecting private subnet to the internet, we will have a NAT gateway. And now, what else do we need to do? Update our map, our route table. So the map for the public subnet says, if you are going to the internet, go through this gate called the internet gateway. But now the route table for a private subnet will say, if you are trying to access the internet, please do not go through the internet gateway. Go through the NAT gateway, and the NAT gateway will send your traffic to the internet through the internet gateway. So on that end, this is how a route table looks like if I am imagining it from the world view. So in a private subnet, the route table will say, okay, are you traffic within the neighborhood? Like, do you live here locally within the VPC? Then that is okay. You just go around. But if you want to go to the internet, then make sure you go through the NAT gateway. That is the most secure way. And for our public subnets, what will say that, okay, still, are you local traffic? Are you within the neighborhood that is within the VPC? Cool. You just go around, talk to whoever you want. But if you're trying to access the internet, then you need to exit through the internet gateway. So this maps that, like, whatever this is now what the root table is. Okay, so I'll pause for any questions in a moment before now we get into a demo and then security. Any questions so far? If you are getting stuff, if you have moved from 0 to 1, 1 to 2, you can let me know in the chat how it's going as well. So either +1 if you're getting something, or -1 if I am confusing you. Okay. Karen got a +1, +1. It's going well. The rest, or 0 if, yeah, you could be neutral as well. Okay, I'm glad. I'm glad I moved Francis from 0 to 1. Thank you so much. Okay, Kevin, I love that. So, Peter, maybe I can summarize at the very end. So we are doing well on this as well. Okay, so let's continue. I'll just do something small, explain what an elastic IP is, because I said the NAT is going to have the network address translation, or the NAT gateway is going to have an elastic IP. I don't know why AWS called it elastic IP. Okay, maybe it's because, why? Because an elastic IP is just a static IP, an IP address that does not change. Literally, like, it does not change. So the elastic, we'll get into that. The elastic IP is just a static IP. It does not change. Why do we need a static IP? When I create a server in AWS, and then I stop that server, like, there is a physical server somewhere in some data center. And when I start a server in AWS, it's just a virtual server. So we call it a VM, a virtual machine. So when I start it, it's going to start on some physical server somewhere in South Africa, whatever. When I stop that server, because one of the benefits of moving to the cloud is getting the flexibility as well, and so on. When I stop it, it might start in another physical machine. So what happens? One, we are going to lose the IP address, the public IP that was attached to it. Why are we going to lose? We exhausted all of them. And that is why we are moving towards like IPv6 and so on. We exhausted all IPv4 addresses that are available. We became too many on the planet. And each person has, like, for me, like where I'm sitting, I'm having like 1, 2, 3, 4. I think I can cut around 5 devices already that need like an IP address. So we exhausted them. So in short, we are sharing. So if you stop, we are going to take that public IP from you, give it to someone else who needs it. And then when you start your machine, we'll give you another IP. So you can see how that can create a mess. So in such a way, you might want to assign an elastic IP, which is an IP that does not change, but you're going to be charged for that because even if you stop your server, you still like need access to that static IP as well. So one of the benefits of it is if I have an IP that does not change, it can help me with failover purposes, because if my server goes down and I launch another server, I can detach this elastic IP and attach it to another server, and my application will still be reachable from the same IP address. So that is literally it. Best practice, make sure you have your, applications across multiple availability zones. As you have mentioned, AZ is a, collection of multiple data centers. So you can see this architecture that I have over here. I have the public subnet. It has the NAT gateway in it, but I make sure it's available also in a second availability zone. Basically, the purpose of AZs is to achieve high availability within the cloud. So in case any issue happens, NAT gateway 1, maybe something happens in this availability zone, floods, floods sweep out Nairobi, will still be accessible, or our application will still be accessible even though we are dead. Anyway, even our servers themselves, we make sure they're available in multiple availability zones. We can use a load balancer to distribute traffic evenly. So that is quite a nice architecture to go with. So let me go a little bit on the console and show you how we do all these things. So where am I? North Virginia. So we have been discussing VPC. Do a quick demo. Okay, so I saw a question as well from Billy. What is the cost implementation? Oh, not implementation, implication of using the NAT gateway. So one of the things first is when you create a NAT gateway, it comes with this elastic IP. And I mentioned this elastic IP is something that you're going to be charged for. Actually, cost you a lot when it comes to AWS is leaving your NAT gateway if you're not using it. I've learned it the hard way. It's one of the major components of the VPC, which you're from the elastic IP and the NAT gateway. It's basically, free of charge. So that is one of the, cost implications that come to my gateway has its own charges. Let me see if I can get like the charges per hour of the NAT gateway. NAT gateway AWS pricing. So yeah, the NAT gateway is charged on an hourly basis and the rate is this. And that is only for just the NAT gateway itself. We also have like some charges due to how much data is processing per hour and also the elastic IP that is attached to it. So that is it. So not bad, but you can imagine if you leave this running for a couple of hours, it might, skyrocket your charges. But it's always a cost analysis, cost versus value. There is that value trade-off. If you want to make sure like your services are secure in such a way that they do not access the internet, for example, the database, you just have to pay for the NAT because why not? So just creating, I'll do this bit by bit. So first, I create a VPC. Who do I call this VPC? Who is here? Who can I see on my screen? Let's go with Franco. So we have a VPC called Franco. I have to specify Masaida block. So that is that big hotel room. So I'll just choose a simple one and then I'll go and create it. So that is just how simply you create a network. So it has this network address associated with it. That is the address of the network. And any servers I launch will get an IP address from this specific network. After that, I go ahead and create my subnets. So I can go ahead, create a subnet, select which network. So I'll say Franco. Subnet 1, so I'll call it Franco pub sub 1. What did I write? So the availability zone I can choose where, remember the VPC is within a region, in this case, North Virginia region. The subnet is in a specific availability zone. So I have to choose one. So I'll choose with A, I'll choose A, and then I give it a number within that block. So 10.0. I just do 0.0/24. And IP addressing is a whole thing on its own, like subnetting and whatever, but don't worry about that for now. And then I can add another subnet. So this was the public subnet 1. And then I can add, a private subnet. But to remember from my architecture, I actually recommended having, multiple subnets. Like if it's public subnet, have 2 of them. But I'll just create a public one and a private one. Now, I just named this subnet private, but does that really make it private? Same settings as public. I say this is also in 1A. And then I give it 10.0.1.0/24. Shorter range. And you can see it's telling me I'm going to get 256 IP addresses to use within this subnetwork. So I'll create those subnets. But what you have noticed is the only thing I have done is naming. But does naming make a subnet private or public? So what I'm trying to say is by default, even though I named this subnet Franco public, it's still private. what makes a subnet public comes to what I told you before. It needs an internet, a route to the internet gateway. We need to specify this subnet has this route which goes to the internet gateway, and that is how my naming will actually make this subnet public. Otherwise, it's just private. If I take a look at it, you can see the routes. And the route over here, come on, why? Now let me refresh. And if you have any questions, keep them coming. I'm constantly checking through the chat as well. So let me see the route. And you can see it has one route, the one I called local, saying any traffic within the VPC is allowed. But we don't have a route to the internet gateway. So what is the next thing? I create an internet gateway. Simple setup, I call it the Franco Internet Gateway. And after I create it, am I done? No, I have to attach it to my VPC. So I attach that to the Franco VPC, attach the internet gateway. And am I done? Are now my resources public? No, I still have to go to the route tables and make sure that I have a route to the internet. So I'm going to create a route and call it the Franco public route table, attach to the Franco VPC, create the route table. Of course, it will come with the local route. Like, are you local? Any traffic? Is that traffic within the VPC? Yes, it's allowed. And then I edit the route and add another route and say, if traffic is going to the internet, that traffic should go through what? The internet gateway, which is the Franco internet gateway that I created. And I save the changes. And am I done? No. After I create the route table, now I have to go and associate that with the subnet. So I'll say now this route table is associated with the Franco, public subnet, save the association, and that is what now makes my subnet public. Otherwise, it was not. And then, what else did we discuss? The NAT gateway. So for the NAT gateway, you just create it, create a NAT gateway. I'll call it the Franco NAT. I'll come to that. So I'll call it, Ijeoma. Just give me a moment. I'll call it the Franco NAT. And then I specify the VPC, Franco VPC. And then it needs an elastic IP, as I mentioned. NAT gateway will always have an elastic IP attached to it, which is a static IP. So I'll just say automatically attach that, assign that. I create the NAT gateway. But after creating the NAT gateway, it will only be of use to me if I have a route to the NAT gateway for my private subnet. So the next thing is probably the route table. I can create my own Franco private route table attached to the Franco VPC, create it. And then for the routes, I edit the route and say any traffic going to the internet should now go through the NAT gateway. And I select the NAT gateway that I have created, save. I think that is because the NAT gateway is not ready yet. I'm super fast in there. So I'll just wait for it to be available and retry. Let me check. Really? I'll get back. You don't have to float. So I specify the NAT gateway and then I associate it with the subnet. So I'll say I want to associate it with which subnet? Now this is the private subnet. So whatever I have done till this moment is everything that you are seeing basically in this diagram. Let me go back and clear maybe a screen. So what I did, I went ahead and created a VPC. After created VPC, I went ahead and created two subnets. Subnet 1, I called it public, and subnet 2, I called it private. After doing that, I went ahead and said, but what makes a subnet public? Is it naming it Franco public? No. I have to attach a route table that has a route to the internet gateway. So the next thing, I went ahead and created an internet gateway called the Franco Internet Gateway. I attached it to my VPC, and then I went ahead and created a public route table, which looks exactly like this. So the local route was for the IP address of, the CIDR block of the VPC. And I said if traffic is going through the internet, it should go through the internet gateway that I created. That is the first step I did. And then the second bit, I went ahead and after creating a private subnet, I created a NAT gateway here. And this NAT gateway has to be in the public subnet as well. So you select that, and I go ahead and specify, if traffic is going through the internet from the private subnet, it has to go through the NAT gateway. So that is what I did to my route table. And finally, subnet association. I associated that route table with the private subnet. I associated this route table with the public subnet. That is the only thing I have done. Maybe I was just too fast on the console. Irene, anyway, I have recovered you. Hopefully I'll recover you in some way, but it's just the concepts we have been discussing, that I have proceeded and worked on. The only thing I have not created is literally the server in this case, but that is how you build your network. Ijeoma asked me the CIDR range. Now, when it comes to subnetting, it's a whole big topic on its own, but I love this link to use it to do the calculation. When I was learning subnetting, I had to calculate with calculators and whatever, but now we have these tools available. So for example, how do we differentiate a CIDR block? So for example, I like choosing numbers which are 0 because it makes sense. So this tool is actually really nice to help you figure out which network is good. For example, for me, when I selected the VPC, I selected a /16. What /16 means, as you can see, all these numbers are converted to binary. And in their conversion, when they are converted, because literally, computers don't understand our language, right? They talk in zeros and ones. So if we do this conversion to binary, this is 10 is this, 0 is this, 0 is just 0, and so on. So when you say a /16, remember I said that this number, which is called a subnet mask, enables us to know how many rooms we have in a hotel, which are literally how many hosts or devices, how many IP addresses can we give to devices within our network. How does it work? So /16 will say that I reserve the first 16 bits. You can see these colored ones, purple and whatever that color is. I think I'm still with the colorblind people, but not so much. So I don't know if this is orange, red, or somewhere in between. Maybe red or I don't know. Let me know. So you can see the first 16 bits have been reserved. So what that means is this 2 cannot change. 10.0 cannot change. That has been assigned to the network. And now we have 16 bits remaining, this which are gray in color, which you can use. So I can use 0 and 0. I can choose to have 1, 2, 3, 4, whatever I want in here. And now after it calculates for you and it tells you, if you do a /16, that means you have 16 bits remaining. 2 to the power of 16 gives you around 65K. So this is telling you that you can actually have 65,000 IP addresses within this network. And the bigger the number, if I continue and do maybe /24, it's just telling me the first 24 bits. So you count 24 from here to here. That belongs to the network. So 10.0.0 cannot change. That is literally the hotel name, like Weston. And now 0 is this number, or X is what you can assign to the room numbers. 0, 1, 2, and whatever, till you get to 256, because 32 minus 24, we only have 8 bits remaining to assign to hosts or devices on a network. So 2 to the power of 8 is what gives us 256. So you can only have 256 addresses within this network. So what I was doing, the CIDR range, what I was doing on the console, I selected a network, VPC, which was a /16. And /16, it told me This big VPC you have created, you have around 65K IP addresses. But I know 10.0 cannot change. If I create a subnet, I have to subdivide this big network. So I went ahead and created a subnet which is /24, meaning I can change the next bit. So the first one was called 0, and the second one, I did it number 1. So I just changed this value over here. So my subnets are a smaller versions of like subdivisions of my VPC. And now each subnet I created only gave me like 256 IP addresses. So I know it's a big thing. And yeah, getting the whole of subnetting, I don't expect you to like get it within like 5 minutes or 10 minutes as well, but I think this lays a foundation of how I chose the cider range and whatever. So but please, Ijoma, I can share some resources as well which dive deeper into the subnetting topic. But this tool I have shared on the chat, it's actually a good starting point if you really don't know what IP to assign to your network and how many IP addresses you're going to get. The further you go, if I choose like a /28, you can see 28 bits assigned to the network. I only have 4 bits remaining. 2 to the power of 4, I can only have 16 addresses or 16 IP addresses within this network. So that was the whole cider range. Anyway, for the people who I'm trying to minus, hopefully I'm not minusing from our knowledge. We were going to pluses and pluses. So, but yeah, thank you, Franco. I tried my best. I know subnetting is a big deal, yeah, on cider blocks. Okay, but we have done the major things, the components of a VPC, subnets, route tables, internet gateway, NAT gateway. Let's do a quick refresher. Match VPC components. So I start with number 1. You can let me know on the chat if the option is A, B, C, or D. And I know some topics are yet to be covered, so I'll cover that as well. If I want to isolate databases containing personal information, which choice would make sense for that? For me, I will answer question number 4. I will answer question number 4. So let me know in the chat, just A, B, C, or D for this. Come on, come on. Franco says B, 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 B coming in. Someone already answered. Okay, so the B's have it. So let's check. So that is correct. So for 1, it's B. Let's go for 3. If we want to support a customer-facing website. So 3, what is the answer to 3? So 3 goes with A from Nelson. A. So the next topic we'll be discussing this later on. Okay, that one I have answered. I say the last few I'll answer. Creating a VPN connection for virtual private gateway and establish a dedicated connection is direct connect. Those were mine because I will answer them later on. Okay, so we are done with the first part, which was just understanding the basics of networking and the VPC architecture. So I hope you are good with that. We are moving on to the next topic. I love it. How do you secure now that network you have created? What are the types of firewalls that we have available in this case? And we have 2. Network access control list, firewall number 1, and security group, firewall number 2. Where are they within our network? A customer tries to access Amazon.com. Amazon.com is hosted here in this server, which is in a public subnet. They send their information, whatever, want to log in through the internet. They come in the VPC through the internet gateway. Before they reach our subnet, there is this big boss here, who is a firewall, called the network access control list. And the network access control list, the purpose is to check the rules. Who are you? Like, are you allowed? And it's not the person, it's this packet that is coming in. It will, what type of packet are you? What type of traffic are you? And let me check my rules and see if you are allowed to pass in. So this is firewall number 2. And the packet says, okay, I was able to pass in. So this is the packet. And then they come into the subnet and they're trying to get to EC2. Boom. They get another security guard over here called the security group. And the security group will say, hold up, hold up. I understand you are able to go through the subnet, but, and remember the subnet was like the, in our hotel analogy, we had the floors. So floor 1, floor 2, floor 3. So it was like, okay, the elevator allowed you to access floor 1, but now we are getting into the room. I have to check. Are you allowed to get into room number this? And let me check and get back to you. So those are the 2 types of firewalls when you think about networking in AWS. But they all function differently. So let's get started with the network access control list. As I have mentioned, before you hit the subnet, you're going to get this firewall called the network ACL. We call it the knuckle, not these ones. So if you hear me saying knuckles, I'm not talking about my, hands and whatever. So it's just the network access control list, who is a firewall who by default allows all inbound and outbound traffic. There is that
Hello.
VPC I created within my console.
Hello.
Hello. Hi.
Sorry for interfering. I
Yes,
don't know
please.
whether I would like you to, if you can maybe get some notes. Maybe I came in late, so I don't know maybe how you can help.
We'll figure that out. I think there is a recording. The team will share as
Okay.
well. Don't worry. I hope so.
Okay.
I think so.
Okay.
Yeah.
Okay.
But I'll also share this presentation, okay?
Okay.
Okay, cool. So back to our firewalls. We have the network access control list, who by default, this security officer, what I mean by default is like the way they were, when they get to work, they did not know anything. And they were told, because you don't know who is allowed or who is denied, you just allow everyone in and allow everyone out. But if I create a custom one, now I start to train this firewall and tell them, uh, if I create a custom one, they will deny all inbound and outbound traffic. So they won't allow any traffic at all. And now I start adding rules. And then now before I get to that, so that is network access control list, the firewall at the subnet level. We do have the security group, who is a firewall at now our instance level. Just because you entered the subnet does not mean you can access our instance. And by default, now this is another firewall. This one now denies all inbound. If you are coming in, by default I deny unless I was told, to allow that traffic. So there is one thing I want you to understand when it comes to the difference between network access control list and security group. We normally say the network access control list is stateless. Try remember stateless for now, like does not remember. And then we do have the security group, and security group we normally say is stateful. For now, think of that as remembers. Now, I love stories, so let's go and have a story. Okay. I am having my wedding. God knows when, but we will have my wedding. So my wedding is going to be, yeah, in Nairobi, Kenya. And I assume all of you don't live in Kenya, right? Hope no Kenyan here, I assume. Only me. I'm the only one based in Kenya. So the likes of Kevin Tuwe will be coming in from Rwanda. The likes of Joshua will be coming from Ghana. And Nigeria, or let me know, or whatever. I'm guessing. So yeah, invites will be sent to every one of you. Now, assume Kenya is my subnet. And the reception, I don't know what is a nice reception in Nairobi. I'm not a fan of weddings, but I'll have mine. That's why I'm inviting you. So the reception is somewhere in Nairobi, some grounds in Nairobi. Now, entering the airport, you guys, all of you who are coming into Nairobi for my wedding, you are all going to come to Kenya and land at JKIA. And at Jomo Kenyatta International Airport, you will get this passport control officer over there. And the passport control officer will check, can you show me your passport, whatever, whatever. Let me check if you are allowed to come into the country. And if you are allowed, you come in. But there is Irene here who was not allowed. Irene had a fake passport. Sorry, Irene, I have nothing against you. I'm just using names. So people were allowed, and the likes of Irene were told, you know what, just go back to your country. Like, you're not allowed here. And for the people who are allowed, who are the majority, they get to Nairobi, they rest, whatever, whatever, and it's a nice Saturday morning like today. It's sunny out here, and Pauline is very ready to get married. So you guys come at the reception. At the reception, you will get a guard, like, we normally call them bossy or whatever you call those people. So you'll get them over here, and the guard will be like, do you have your wedding invitation card? So if you have your wedding invitation, because you are techies, we'll have the online version. Yeah. So if you have a wedding invitation, you come in. If no, you know what? Go for maandamano. You can be somewhere else. And now you are able to get in. Now, what about leaving? Now you are in the grounds and you are there saying, oh, 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 and you're crying and everything is beautiful. And now it gets for time for the gifts. For the gifts, all of you have these big cars. So we have Anastasia who has parked her big Mercedes-Benz out here. And Anastasia comes and says, oh, my gift is that, 100-inch smart TV. That is me just being my Delulu self. Allow me to just think about it. So Anastasia came and gifted me that, 100+ inch smart TV. And she has to go pick that out in her car. When she leaves the venue, the guard will not ask her, where are you going? If you came in, you can go out. That is at my wedding place. If you came in, that meant we checked and you had your invitation card. That security guard over there will be like, oh, you're going for the gift. Okay, see you. And Anastasia will leave however she wants. And when she comes back in, there is a high possibility this security guard will know who she is. She'll be like, oh, madam, you're back. Okay, come in. So, traffic that was allowed in, sorry, I'm calling you guys traffic, but traffic that was allowed in will automatically be allowed out. And if the same traffic comes back again, it is likely that this security guard will remember, I saw you before, you just come in. Without checking, do you have your invitation card still? And that is how the security group works. The security group is the firewall at the instance. It remembers. If I allowed you before, you can come back again. But now the wedding is done. They have told me to stop dreaming. Okay, the wedding is over. You can go back to your countries. And all of you leave and go back to the airport at JKIA. At the airport, you're going to meet this passport control guy. What is the likelihood this passport control guy will remember you and say, oh, Anastasia, I know you came in, have a safe flight back? It's very unlikely that they remember you. They'll be like, again, who are you, stranger? Where are you going to and why? Show me your passport. Let me see if you are allowed to leave the country. So the passport control of the officer at the, JKIA did not remember you. He had to check rules, inbound and outbound. If you come in, we check your passport. If you go out, we check your passport, because I don't remember if you even came in. I mean, I have seen more than thousands of people today. How can I know it was you? Now, the security group is like, we can say the door attendant, or, that officer like where my wedding is hosted. You say, I am leaving. I'll be back. And they'll be like, okay, I see you when you get back. And you come back and you say, okay, I'm back again. That guard will be like, I remember you. Stateful, remember. Stateless, not remember. Okay? Stateful is remember. Stateless will not remember you. So stateful is how security group works. If you leave, they'll be like, okay, go away. If you came in, you can leave out. If you came to my wedding, you can go out as you wish. And if you come back again, it's okay, remember you, get in. But if we go back to network access control list, stateless does not remember. If a packet enters the subnet, they will check to see if you are allowed on its list. And if you leave the subnet, it will be like, I don't know you. I don't know if you came in. I want to exit. They will be like, okay, I will still check to see if you are allowed to go out. So that is the difference between network access control list being a stateful firewall and a security group being a stateless firewall. And they all just contain rules. Here is an example of a security group rule. I'm saying traffic from anywhere coming in TCP, that is port 80 HTTP traffic is allowed. HTTPS traffic is also allowed in. So if I come in with my own, I don't know what traffic, my SQL, I'll be blocked because that is not allowed in. And outbound, one thing to note about security group, these outbound rules don't matter a lot. If anything came in, it's just by default allowed out. So I can specify some rules over here, but as long as port 80 traffic came in, port 80 traffic will always be allowed out, and so on. But network access control list, that passport control officer, all traffic, you can be allowed in and denied out. And that brings me to one of the troubleshooting things you normally do at AWS. You go check a specific IP address and you see your VPC logs and you see like there was this IP address, let's say 192.168.10.15. Like, and then like it said that this was moving to my server 10.0.0.1. And then this one was accept. And then you see like from 10.0.0.1 to 192.168. whatever, the traffic was reject. And now you wonder, what exactly could the reason be? From our discussion, this is probably a network access control list issue. Go check your network access control list, because if it was a security group, if this traffic was a fault, but if you see there was one-way accept and one-way reject, it is most likely to be a network access control list. So that is me saving you time on troubleshooting. If you ever see like some traffic was allowed in and not allowed out, or some traffic was allowed out and not allowed back in, you know security groups, remember, they will automatically allow in. So any such troubleshooting scenario, go check your passport control officer, the network access control list. And that wraps up the two major, firewalls I wanted to discuss. So if we compare the two, security group is attached to the network interface. That is basically the server EC2. Network access control list is attached to the subnet. Security group has only allow rules. Network ECL can have allow or deny rule. I invited you all to my wedding and we have discussed stateful versus stateless. For now, remember, stateful will remember, or in other terms, any traffic allowed in will automatically be allowed out. But stateless has to check rules both ways. Like if you're allowed in and you want to go out, I still have to check my firewall rules and so on. Security group will just check all rules to decide whether to allow traffic. But if you create a network ACL, you'll realize you have to give it a rule number, 1, 2, 3. So it will always evaluate the rules in order. Security group applies to an instance if it's associated with the instance. Because network ACL is at the subnet level, all instances within that subnet will be associated with that network access control list. Any questions on security group versus network access control list or security within our VPC? If no question, +1, -1, or 0. If we are moving together in your scores, let me know in the chat. Okay, let's see. Okay, at least it's 2 + 1 + 2. Amazing. I love that. I think majority of these people will now be past 10 and so on. So let's continue now. The last part, we are literally on the last part of our lecture. And now that we understand networking at a basic level, the next step is to understand how does interconnectivity work and how do services communicate with each other. So I'll start with VPC endpoint, which is aimed to answer the question, how do we keep, connections to AWS services private? The answer is VPC endpoints. Now let me explain why. If you launch a VPC, why do we have a VPC in the first place? To give us a network so that we can assign resources IP addresses. Which resources need IP addresses? Probably EC2 and maybe some database server and whatever. Like only a few resources need to be within a network boundary. Think about the different AWS services you know. You know S3, you know DynamoDB. Lambda can be in a VPC, but by default, no. All these services, there is nowhere if you create a bucket, they will ask you to set the VPC where it's going to be created from. So what you're getting from this is majority of 200 plus services are actually not bound within a VPC network. They have like public endpoints to access them. An example is S3. So hopefully you are all familiar with Simple Storage Service, which is an object storage solution. So we have this EC2 instance. It needs to access a DynamoDB database. This is a serverless service. If it's serverless, there is nowhere we define a network because we don't even access that server. Why would we need to know the IP address of it? It's a serverless database. If we do not have a VPC endpoint, what normally happens is this instance will communicate with this service through the internet. So it will probably go through the NAT gateway, if it is in a private subnet, to the internet gateway and make an call to DynamoDB. So to consume these 200 plus AWS services that are not, do not live in a VPC, that traffic will have to go through the internet. But now we have a solution which is called the VPC endpoint that allows us to connect to these 200 plus AWS services privately. So we have two types, interface endpoint and gateway endpoint and so on. But I'll just talk about endpoints at a high level. So it's literally a network interface, ENI. If you have dealt with the physical world, you have had maybe something called the network interface card. And the network interface card is somewhere on your laptop where you connect like your Ethernet cable and it allows that network connectivity. So that thing on your laptop called the network interface card in AWS is the Elastic Network Interface. That is what we call it, ENI. And it has its own private IP, public IP, and even the MAC address of a server associated to it. So literally, any address is always associated to the ENI. So this VPC endpoint, it will make much more sense in a diagram. It's just an elastic network interface which has a private IP. It is managed by AWS. So when you say a service is managed, AWS takes care of things like scaling, redundancy, and high availability. AWS promises that it will be like that. So if it's not highly available, we go sue them and make millions of dollars, okay? So, but how does it work? The diagram will make much more sense. We have our server here in the private subnet, and this server needs to communicate with DynamoDB, but we do not want it to communicate with DynamoDB through the internet. If we do not have a VPC endpoint, That traffic will go through, for example, the NAT gateway here to the internet gateway. But if we have an interface endpoint, it's like just an endpoint, and it's, directly associated with DynamoDB. So what you are trying to do, it's like we're bringing DynamoDB in here, like this database. Don't know how to draw it. It's like we're bringing DynamoDB here, so that the EC2 seems like it's interacting with DynamoDB inside the VPC, but in reality, that is not the case. So this endpoint, it's just like a private troopers. I don't know why I used that word. A private troopers to DynamoDB, so that we do not go over the internet. And now you can see the root table for the private subnet does not have to change. It's now like we have brought DynamoDB locally, and so on. So that is how the endpoint work in this case, and that is how you interact with, all these other 200 plus services. I think right now even it might be more than 300 by now, privately. So just to show you where to create that, I won't go with the nitty-gritties because I don't even have a server to communicate with S3 for now. So we do have endpoints still under the VPC, and then I can create an endpoint. And I want to say this endpoint, I've been torturing the name Franco today, is to access or connect to AWS services. And now you can see we have like 554 over here. Some are repeated and so on. For example, S3, I can just search for, the service name is S3. And I want my server to access S3 because S3 is a public endpoint. You get like, it has its own DNS. So it's a public endpoint. So I can say I want to create an endpoint for S3 and it will be accessible from which VPC. So if I create an endpoint for S3, it's like I'm bringing S3 inside the VPC, though S3 is a public service. And now I go ahead, create an endpoint for that. And if I ever have any private resources that will try to communicate to S3, they will never now pass through the internet gateway. So that is the purpose. It's solving the problem. How can we keep connections, not to other networks, but to AWS services, private? So it's like we bring those services inside the VPC, and the VPC endpoints help us with that. Now, I'm done now I'm really now going to interconnectivity. How do you connect multiple VPCs, You have VPC 1, that is mine. And then I have VPC B, that is Alex. I see Alex on the call. Those are two different networks. In my network, I host the compute. But then Alex has this amazing database that I did not buy, but I want to access it. So Alex has like a very nice database I love in his network. So how am I going to connect my network with his network so that my server will be able to communicate with the database in Alex's network? And as Nelson mentioned, VPC peering comes in. So connecting two networks together. It supports intra-region, same region, or inter-region, different region. I could be in the US, could be in the Europe region. It's still okay. It also supports cross-account, as I have mentioned, or even same account. And what do you do to set up peering connection? We need a route. Remember, the route tables are very important because they are our maps which define how we are going to communicate. So you can see now we have an additional route in our route table. We are saying VPC 1, you can see 10.1, that is local. Any resources within this VPC can walk around the neighborhood. But we need to add a route. So if you want to access 10.2, then you have to go through this peering connection that we have set up. So a peer is a friend, and that's it. One thing to understand, IP spaces cannot overlap. That's why you can see this is 1 and this is 2. It's like I cannot have a same number with you and call you. You need to have a different number, so my phone knows how to reach you. If we had the same numbers, my phone will be confused. Will be like, should I call myself or should I call, Rachel? So It's like you cannot have the same IP addresses or an overlapping one. So they have to be different so that the communication can be established. Rule number 2, just because, let me mend my times with Irene after telling her she was not allowed to my wedding. So here I am, Pauline. Here is Irene. And then Irene is a friend to who? Irene is a friend to, let me say, Nelson. So I have established my peering connection, so it's like a friend request. I told Irene, will you be my friend so that I can access some of the resources in that amazing network of yours? Irene said yes. Okay, yes, you can be my friend. And now we do handshake. And now we are peers. Irene, on the other hand, loved Nelson's Nelson drives what? I don't remember. Let's say G-Wagon. So there is a G-Wagon in Nelson's VPC, and I really love that and will be like, oh, Nelson, can you be my friend? So it's like, why not? You are also in the AWS world. I love AWS people. They do handshake and they're friends. So what you're saying by no transitive pairing is just because Pauline is a friend of Irene does not mean that, and Irene is a friend of Nelson, does not mean that Pauline can now go ahead and start riding Nelson's G-Wagon. It is not possible. If I love G-Wagon, the Nelson's G-Wagon, I have to go and say, Nelson, can you be my friend? And until Nelson accepts, and I set up my own peering connection to Nelson. So what you're getting over here is VPC peering is one-to-one. And just because you have paired with one and one has paired with another does not give VPCA direct access to VPCC. So that is another rule. So we are getting one-to-one connection. What are the benefits that you are getting? This connection is private. It does not go through the internet. So we are not using the internet gateway. It's highly available. We do not have bandwidth because majority of the time we only get bandwidth issues when we are trying to access the path which everyone is working on. That is the internet. And we are using private, IP addresses to interact. So that is communication. Real world use case. Now let me stop with my analogies and G-Wagons. Where would VPC peering make sense? I have an application in region A, another application in region B, another application still in region A. But they are accessing some shared services. I don't know, this looks like maybe database or storage. Maybe there is a database solution or a storage solution, or think even security tools like scanning tools, security scanning. We are doing some vulnerability testing. And all those services are hosted over here, but our applications live in different places. So one use case of VPC peering would be this. I pair VPC1 and the shared services VPC, same with 2 and same with 3. And all of them can interact with these shared services. But what you see is these VPCs do not have communication with each other because they are isolated. So that is what they mean, but you cannot use the shared services VPC as a transit point, like to access the other VPC one-on-one. But this poses a problem. They call it a full mesh architecture. I call it a mess. This makes sense for small friendship groups. Me, Irene, Nelson, and then we can add who there, Eve, and so on. But the more our circle is getting bigger, the more a mess we are making. Because this is one-on-one. So imagine we only have 5 VPCs over here. But if they need to communicate with each other, I need to send peering connection there, another one here, another one here, another one here. And even once I'm done, it's not enough. I need to go to my Google Maps, my route table, and start telling it, if you want to access A, go through this route. If you want to access C, go through this peering connection. You can imagine this is a route table for only one VPC. And then I do the same for this one. I do the same route table for this one, specifying the routes. Even me as a network engineer, I don't like this work. I'll make errors, I'll confuse stuff, and services will not be able to access what they're able to access. So if you have thousands of VPCs. For me, I'd just say even a minimum of 10. Let's start from 10. If you have like more than 10 VPCs that need to establish a connection to each other, we have a different solution. VPC peering would just not work out. It would, I mean, if you love that job, you can do it, but we are just saying it's going to be so cumbersome of a work to work on, updating all these root tables and maintaining the peering relationship. Now imagine I just come and add another one here. Now I still have to go back to VPC A, add the exception, go back to VPC B and set up the roots as well. So that becomes a problem, and we are going to talk about the solution. So, but before we talk about the solution, I'm going to cover a topic on hybrid networking. We have talked about the cloud a lot. All these things you are doing are in AWS, but you have your own data center. Yeah, you are the likes of Safaricom. You had your own data centers before even AWS got here. So, and now you're trying to use AWS. So you have your own network here, and now you have the AWS network. How do you connect your on-premises network to the AWS cloud? We have two options. One, site-to-site VPN. So site-to-site VPN is literally a VPN connection. A VPN, think of it as a tunnel that enables communication. You are going to set up two things. There is this router on the customer side you are going to set up called the customer gateway. On AWS, you also need a gate. But now it's not called the internet gateway, it's called the virtual private gateway. So if you see virtual private gateway anywhere, this is a gateway that enables us to set up a VPN connection, a tunnel that enables your data center network to access your AWS cloud network. The only thing is, this network, I should be sharing my screen. Can someone confirm, please? My screen is visible.
Yes, yeah, yes.
Okay, okay. Eric, maybe, I don't know, you can try rejoin and whatever, see if it works out. Yeah. Okay. So this network is, the thing is, this traffic is going through the internet, but it is encrypted for sure. But then there are organizations who don't want this at all. I had a training with a banking company once upon a time, and they wanted to actually do this connection, but site like public connectivity was not an option for them at all. So what will such a company do? That is where Direct Connect comes in. So what is Direct Connect? Direct Connect is actually a dedicated physical connection. It's physical, dedicated to you. How does it work? There is this AWS cloud, some region somewhere. AWS has set up the, I'll say, fiber optic connection going through around the world through the oceans. And then they come and then maybe they terminate at somewhere in Mombasa, where I'll say Liquid Telecom. You can think of, because I know Liquid Telecom is a direct connect partner in Kenya. I don't know any other. You can think of a major internet service provider you have, and they have their cabling. I remember some time back, we were told like the sharks, ate the cable somewhere for the green company. Anyway, we have these big or internet service providers. They have their own connectivity. So what AWS will do is talk to these people like Liquid Telecom and tell them, you know what, we have our cables. Can we terminate them on your location in Mombasa? Because that is where I believe the ocean cables could, meet from the ocean to land. And then Liquid Telecom, yes, okay. And then they set up this, it's a partnership with AWS. Now, me as a customer, I have my own data center, and I cannot stand sending any traffic over the internet. So what I will do is I'll come and talk to Liquid Telecom and tell them, I hear you have some AWS, cabling terminated like an AWS router on your facility. I want to set up Direct Connect. And Liquid Telecom will tell you, okay, we are going to set up your own router. interconnect it with AWS. All this is physical, remember? Physical fiber link. And then we are going to set up the fiber link connection between your data center and us. So you can imagine this is something very expensive to set up because it's physical connectivity. Now, what are you noticing? If this one is interconnected, and here it's interconnected to AWS data center, and here from the customer router, it is interconnected to your own data center. At the very end, we are getting a physical connection directly from your data center to AWS. This will take months to set up. So sometimes you get questions like, I need to connect my data center to AWS, but I only have 1 week to do that. Literally, it won't make sense. Who will do the cabling and, in 1 week? And even that 1 week, even you have not signed partnerships and whatever, it literally takes, some months. I'd say like they normally say in the documentation 1 to 2 months, but I have this feeling that only works in some countries. Here it could take like 6 months for you to even now sign those things and now start the cabling. So this is expensive, yes, but you can see you're getting a dedicated connection between your own data center and AWS. So if I was to take an analogy before I come to this, you have your office building and you want to communicate to AWS. VPN is like using a public road, that is the internet, but you have security. So you are literally like your traffic is encrypted, but we are using the public internet. So you can see, even though we are encrypted, we'll still face some issues like bandwidth issues, latency, and whatever, because we are using the same road as everyone else. But direct connect is, imagine you just have your own private tunnel. No one even knows about it. You can drive here with whatever speed you want in your whatever. So direct connect is like having a private tunnel which establishes that connectivity between AWS and your data center. Your data, like your traffic does not have to be encrypted because it's private to you. It's going through the physical cabling. We are not traversing the internet at all. But if you want encryption, you can set that up in combination with the VPN as well. So that is the difference between the two. VPN is easy to set up, like it's very quick to set up, but you get bandwidth issues. Traffic is going through the internet. Okay, my pen stuck. Yeah, internet. Direct connect is a little bit more expensive, but you pay, you pay for what? A little bit more expensive, but it's more secure, more private, more dedicated to you. You really don't need encryption as well. By default, the traffic is not encrypted because why would you encrypt somewhere where no one is going through? Only you and so on. So that is the difference between the two. So when do you choose one over the other? Site-to-site VPN, you can see we have a maximum limited connection of 1.25 gigabytes per second. And one thing I mentioned is, if you see me talking about these values, they might change. Sometimes I just talk about something and then I go to the documentation and I see it has changed. So if these values change, I might not update my knowledge immediately. But if you go somewhere and then see it's 3 gigabytes per second, please forgive me. These values keep changing. But from my knowledge right now, at this point in time, AWS site-to-site VPN is limited to 1.25 gigabytes per second. But direct connect, because it's physical connection, you can choose whatever you want. You can say I want 1, 10, 100 Gbps, because now you are talking to the provider or the AWS partner. You just choose. So you see you can have very good connections. I mean, I have not even experienced 10 Gbps, so I can only wonder what that looks like. So this is faster to configure, of course, because it's just some settings on the console. But direct connect requires special arrangements to do physical cabling to the data center. It might take a while. This one follows the pay-as-you-go pricing model. You only pay for active connections. If you're not having any connections like active data going through, you don't pay. But direct connect, you have already set up the physical link, you'll still pay the likes of Liquid Telecom, whether you like it or not. So your port hours, you'll pay for that, whether you have an active connection or not, because this is a physical link you have set up. Site-to-site VPN is encrypted by default when we are going through the internet, like my bus that I showed you over there. But Direct Connect is not encrypted by default because it's private and dedicated. And wrapping this up, so in like 5 minutes, remember I gave you a problem before. We have this peering connection first. Yeah, literally very, very minimal latency, close to none, because it's pure, physical cabling, yeah. So, truth. Minimal to no, compared to VPN. Okay, so wrapping this topic up on interconnectivity, I gave you a problem. First, I was a friend to Irene, and Irene was a friend to Nelson. And now I was able to send my friend request to Nelson, and he agreed. But now Kevin, Eric, the likes of Felix, thought this friendship good is so cool, group is so cool, and they want to join. And now they are bringing us problems because now I can't keep track of all my friends. So we created a mess before, and I'll just take you back to this diagram we had before. Where is it? Here. So everyone wants to join my amazing friendship group, and you're creating a mess because it's very difficult to manage our route tables. So now I went to hybrid connectivity and bring you up the solution called the transit gateway. So the transit gateway is someone, okay, not someone, it is a service. But we have Nathan over here. Nathan has seen now it's becoming a problem managing these friendships, and Nathan has said, you know what? You people just pay me and I will manage all these friendships for you. So if you want to be a friend to Pauline, you want to be a friend to Kelly, go through me and I will redirect you. And that is what the transit gateway does. We are getting a central hub where all traffic from thousands and thousands of VPCs can go through. So now you imagine we manage all our connections from one place instead of managing from each and every VPC. And I discussed hybrid connectivity because, as you can see, Transit Gateway is not limited to just VPCs, but it can actually connect to your on-prem data center through VPN and direct connect as well. So here is a diagram. The other diagram I had, I only had 5 VPCs, and it was creating a mess on my screen. But now we have the Transit Gateway. We attach, it's just an attachment based. We can say I want to attach VPC A to Transit Gateway, VPC B to Transit Gateway, just like that. The more they grow, I just attach. And I manage all my route tables from here, the Transit Gateway. I can attach it to my on-prem network through VPN. I can attach it to my on-prem network through Direct Connect or any wide area network that I have available over there. And now I'm getting this one place to manage all my connections from. And so this solves the problem where you have thousands, hundreds of VPCs, and you want them to be able to communicate with each other. You can set any isolations as you want. Sometimes you don't want the VPCs to communicate, but all of them to access the on-prem network. So these are settings that you can actually set up the isolation or no isolation. However, you want to segment your network, and it simplifies the, connections that you have. That wraps up, the third part of our section, which was on interconnectivity. How do you connect one VPC to another VPC peering? How do you connect your high on-prem network to AWS? You can use VPN, you can use Direct Connect. If you have multiple networks, you can use Transit Gateway. So that wraps it up for me. I'll pause for any questions, and +1 if, like, now you can tell me where you moved from. From me, I was 0 to 3. I'm now at 3 on networking. So you can let me know, like, if you are able to increase your score on chat. There were those who are 7. I hope I got you to an 8 and taught you maybe one new thing or reminded you something you had forgotten. For those who learned some new stuff, I'm glad you did as well. Jack, you really got to 10, jeez. Okay, thank you for loving the session as well. So I love that we learned something. Thank you, and I guess back to who invited me?
Hi, Pauline.
Back to you, Tim.
Thank you so much, Pauline.
Oh, yeah.
Thank you. It was such an insightful session.
Okay.
We're really inspired because of that. I would like to welcome any questions in the chat box, or if you can unmute your mic, you can ask any questions. Yes, but it is true. We have added +1 +1. Personally, I was 4. Right now, I can confidently say I'm 10.
Really?
Yes.
Okay.
Any questions? Karen says, I hope we can receive the recordings. Yes, we usually upload the videos in the YouTube channel. Once it is uploaded, we will communicate it in the group and then we'll have it. Uh-huh. Any questions? A big thank you to Pauline. Yes, as Kevin has said, it will be on YouTube. Joel says thank you because you really helped him for his next exam. That is amazing.
You're welcome.
All right, Karen, you're not in any group. Aha, nice. I'm glad that you've gotten the link. You're very much welcome. And thank you so much, Pauline, once again. So I think without the questions, we can wrap it up. I had introduced Kevin to speak in the beginning, but he did not have a position to. I think I would like to welcome Kevin and speak to us.
Hey, thank you. Thank you so much, everyone. It has been quite a ride of analogies, and at least today, I'll talk. I have the favor of talking to the president. I'll carry that. I'll carry that along the way. And so, first of all, before I even say anything, thank you so much, Pauline. As always, you bring a lot of energy, and you make AWS look so easy. You know, if I've done a couple of things, I've done things with Google Cloud, I've done things with Microsoft Azure, and I've done things with AWS. But I can tell you, anytime you go into AWS, you feel like you need another level of favor to understand some of these things, and you make it so easy. Anyone who goes through training with you must really enjoy the fact that you know your stuff. And
Thank
I
you.
just wanted to ask you a question. You know, we are okay. Apart from us being an AIML, you know, there's a lot that people are doing in terms of, like, let's say, vibing out things and deploying applications without even understanding what is going on under the hood. We have everything. We have Codex, we have Casa, we have Cloud Code, we have Kiro, name them. So we just vibe things out, and then just if it's not communicating, we just paste the error to the prompt, and it starts getting into a whole hula baloo of it saying it's doing things that you don't even understand. And sometimes you get into that kind of a loop where it's trying to sort things that are not even an issue. It's trying to understand, and if you're not understanding what it is. So what's your take on using, let's say, AIML in networking? Or also, what is your take in terms of what is your position, whether personal or whether from a trainer perspective, in terms of this? Because there's no way you can survive without networking. Even these agents, whatever you're building in the AIML space, require
Yeah.
networking. And definitely, advanced networking is one of the hardest certifications out there. So what's your
Yeah.
take in terms of that in this whole hullabaloo of high vibe coding and spec driven development?
I use it. first of all. So I would say that I do my own things in the console every time. I think the thing is you just need to have your basics right. I saw like a post in one of our AWS WhatsApp groups where someone said like, I have a vibe coded my app, and then they shared a link to localhost. And I was like thinking that everyone will have access to that because it's on the local host. Because so I saw that post and it was really funny. So you see, if you don't know your stuff very well and know you actually need to deploy it somewhere, it becomes a problem. Who will access your application over there? So yeah, I am not opposed. Use AI as much as possible, but use it. How can I put it? Use it in a way that even sometimes you don't understand what is going on, but it's very important that you actually query it because it will always give you feedback to understand what exactly happened, what was the error, and what exactly were you doing to solve it. And that will also be a learning opportunity. So that is how I actually approach, vibe coding, spec-driven development for my applications. And sometimes it's really nice if you know your stuff, because if you just depend on AI, it will take even parts you really had not considered. So it will say, okay, you tell it deploy, and then it will tell you, okay, let me deploy on EC2. But for me, if I have my knowledge right about AWS, I'll be like, but I don't want EC2 because of cost implications and whatever and whatever. So how about we re-architect our architecture to use Lambda, whatever, whatever, and whatever. And it will be like, okay, that makes more sense, even on a cost perspective. So I think just having the basic understanding is very important compared to, just following through whatever it's going to bring up. So use it, but use it carefully, I'd say.
Thanks, I agree. Use it, but use it carefully. As we wrap up, I'd like to really appreciate the AWS Ajira research community, as well as our hosts, Rachel and Jacob, and the rest of the AWS AML leadership, members from all the other AWS communities, that is Pwani, as also as which is the other one? AWS is a group Kenya, as well as all the new AWS student build group leads who have been accepted this year, as well as also those who have been renewed. I just got an email that I got renewed for my 5th year in the AWS community builders. So it's a good thing. At least I know I have one more certification to do and more other things that come with community builders. So for those who are also getting their renewals, we can't wait to celebrate with you. I hope, Pauline, you've gotten yours. That's a no-brainer.
Of course.
Yeah, so that's a big thing that is going on. In June, I think in June or July, the All Builders Welcome Grant will be coming up. So start, as what you've gotten from Pauline, start creating content around it. Start doing not just technical. Don't go to LinkedIn and say, I was with Pauline, I was with Kevin, we enjoyed this. It's not a party, it's a technical thing. So talk about the technical things that you learn from this, and even do an article, do a rendition of it, and you're going to be very happy to do it with you. I'll also be doing a couple of things under Edu Cloud Academy. I'll share the link. As an Edu Cloud Academy ambassador, we're trying to create a network of people who are really good in terms of technical things. They're building their technical expertise. So if you haven't registered, do register here, and you can build on a lot of different things that are there. I'll be sharing a couple of different content on my YouTube channel. We'll also be having this recording on the YouTube channel. And if you have anything, if you also want to speak in our monthly meetups, we usually have these monthly meetups, Saturday, 11 a.m. on every month. Sometimes it happens on the first week or the second week, depending on where holidays are and all those things that are happening in between. Apart from that, unless there's anything I've missed, I'll take it back to Rachel. And again, we really appreciate the time you take to come through for community. Also, congratulations to those who are getting certified with the Terraform Associate certification, which we ran together with EVOPS, as well as HashiCorp User Group Meru. We are seeing your celebratory posts. You're getting your Terraform Associate certification that you're getting. If you haven't missed it, if you have missed it, please, you're going to be having it next year. And I think I have some, last time round, I was asked why does AWS AML not have credits to give out? So I think I have 2 AWS credits to give out. And I'll ask Pauline to decide who gets the 2 credits. Then we'll get their details and share with them AWS credits. Not much. I think it's around $25 or $50. I'll just check, but don't be too excited. Oh, Pauline, over to you.
Oh my goodness, why would you do this to me?
Yeah, because you're the one who have been noticing the engagement on the chat. So
Okay,
the
the
most engaged
engagement.
person, just the most engaged person.
Okay, so I do have a. I do have a couple
Okay,
of people over here. Let me see. You can say something else while
yeah.
I
As
figure
as you
this
do
out.
that, okay, as you decide on the people who are going to do this, is please we also share our link tree. We have a WhatsApp community. We also are on Meetup. All our events are set up on Meetup. Please do check them out. Do register on EduCloud. Anything else, please also, I know Pauline will be sharing her LinkedIn or her socials. She's doing an amazing job with Centibay Consulting, her, her, her consulting firm. So please do click on the link and give her feedback. I'd like you to do that in the next few minutes. I'll reshare the link for feedback. Please give her feedback. It will help her know what to do next. So that is the link to the feedback to the session. Yes. Oh, yeah. Then we are a few days left with call for papers for AWS Community Day that is happening for the very first time in Pwani, in Mombasa at Swahili Port. So if you are having something to share, it doesn't matter whether level 100, beginner level, intermediate or advanced or expert level 400. Please feel free to put it out. Nelson, you can share the CFP link if you have it. And just something to tell you, I'm also one of the reviewers of your CFPs, so do something good. And if I see your name and I can, again, you also see who is going to be speaking. So I'll be reviewing. So make sure you also put it out there. Have a very good, clean profile. Don't have those weird things that make you look like a ghost online. I think, Pauline, are you good now?
Yes, I'm good. I actually
Okay.
used AI to analyze who are they so I don't make a biased decision. So,
Awesome.
yeah, unfortunately, you are the first one, so you are cancelled.
I'm not, yeah.
So, the next one was Karen, followed by Ijeoma. I'm sorry, boys. Franco was after Ijeoma, but Karen and Ijeoma just, yeah,
So,
this is.
by all means, Karen and Idioma, please send Rachel your email, and I'll share with Rachel the credits, and she will share with you by end of day. Thank you. Back to you, Rachel. Thank you, and thank you so much, Oscar, Sharon, Peter, and all the leadership from AWS Ajira Restart. This was such an amazing collaboration. Back to you, Rachel.
Thank you so much for that, Kevin, and also Pauline. Congratulations to Karen and Ijeoma. I have sent my phone number in the chat, so you can send me your email through that phone number via WhatsApp. As we wrap up, there is just one question which have been asked in the group that is to be directed to, I believe, Oscar. The question is, when is the next cohort or for AWS Ajira?
Thank you for that question, but we are not sure yet. In case we have any information on that, I'm sure it will be communicated out. So just hold on. When we are ready for the new cohort, the communication will be sent out. Yeah, back to you, Rachel.
Okay, amazing. Thank you everyone for having your time. You can leave at your own pleasure. Thank you once again.
Think we've forgotten one thing before we leave, Rachel. We do usually do a